Successful completion of the dome over Houston is tempered by worry. The original dream that a city-sized dome would protect Houston from nature's ravages was pure theory. Now builders will learn whether their audacious structure will actually make life better or prove to be the greatest work of folly in the history of engineering. Well before nature puts it to the test, residents will have to come to terms with the dome's impact on daily life.
Having an enormous geodesic dome over an urban area would create a new barrier, but there's no doubt there would be a very real distinction between living inside the dome and living outside the dome.
From the outside, the biggest change would be the view. The dome will become a striking and unavoidable new feature of the skyline. But step across the border and that perspective will be lost. From within, it will be nearly impossible to see the dome in its entirety. Buildings will obstruct the view. And as it arcs overhead, trying to make it out against the bright sky will be difficult.
Of course, you'd see it at ground level, but the higher up you got, it's a very delicate structure, so it almost disappears in the sky. So I don't think you would be aware of the presence of this large structure.
It's somewhat like a screen in your window at home. You see right through the screen because the struts of the screen are very, very small, so it just looks to you as a window that you're looking through.
It will be so unobtrusive that city residents will give it no more thought than they once did of clouds passing overhead. The same clouds that are now outside the dome. Rain no longer drenches downtown Houston, but the sun hasn't gone away. Day after day, it beats down on those thousands of panels, dumping heat into the interior of the dome. Today's featured dish, Houston under glass. Skeptics argue that overheating is the dome's fatal flaw, but Fuller argued that just the opposite is true. Fuller called his domes chilling machines, self-cooling structures with little need for secondary cooling elements such as fans or air conditioners. The secret is in the way that the shape of the structure affects convection patterns.
You're going to find another built-in efficiency by the way air naturally flows in a spherical structure. And the larger that structure, the more you'll be able to take advantage of that relative efficiency.
As air heats, it rises. When it nears the apex, it cools and drops, causing the air to move in what's called a rolling donut pattern. This circulation prevents heat from building up at ground level. But Buckminster Fuller was prepared to go even further. He suggested adding adjustable vents at the top and bottom to further regulate temperature, keeping his dome warm in the winter and cool in the summer. But Fuller's idea was only an educated guess.
We've never done any real experiments of very large, dome to see whether that actually happens or not. It was a very nice diagram that Bucky made. It made a lot of sense, in terms of what he was saying, but that actually would take place is something that I wasn't too sure about.
No large-scale test was available until 2001.
We don't have any air conditioning units to cool either of the biomes. They are only cooled through natural ventilation. We have vents in both the top and the bottom, and that's the only mechanism we use for cooling the biomes.
In Cornwall, temperatures average about 37 degrees during the winter. But one biome is kept at a tropical 90 degrees with plenty of humidity. The other at a desert dry 77 degrees. In Houston, vents located 1,500 feet above city streets will be rigged to open automatically when the temperature inside the dome rises. The vents will create a reverse chimney effect, pulling air in from the outside at the top where it's cooler. As it falls, it's forced out of vents near the base, circulating cool air through the dome. Properly calibrated, the system may also reduce Houston's killer humidity. Fuller believed that the vents would allow a dome's interior to maintain a temperature about 15% lower than the temperature outside, dramatically reducing the need for costly air conditioning.
You could arguably say that Bucky was the first green architect.
Fuller, back in the 60s and 70s, was not talking about climate change, but he was talking about sustainability. So he was an early environmentalist, I guess. And certainly that example points to the fact that the patterns we see now and interpret as such a surprising development were anticipatable a long time ago.